Okay, in this video we're going to cover section 11.4, which is the cross product. Now there are a couple of other products mentioned in this section, but our focus is going to be on the cross product. The section of the textbook is entitled the cross product and triple products, but we're not going to be too concerned with the triple products. We're just going to focus on the cross product. All right, so first let's let A be the vector with components A1, A2, and A3, and B be the vector with components B1, B2, and B3. The cross product of A and B denoted A cross B, well, that's red, A cross B. So again, like with the dot product, we don't want to call this times. We want to call it, you're going to say A cross B because there are two different types of products for vectors. So the cross product, this is actually a vector, whereas the dot, our result of this is going to be a vector, whereas the dot product, what we got was a scalar. So the cross product of A and B denoted A cross B is the vector, and we'll put vector in all caps so that we remember that the cross product gives us a vector. Given by the 3x3 determinant. And don't worry if you're not familiar with matrices or determinants. I'm going to show you how to compute this, and you can either go through the determinant process every time, or you can just memorize the final formula that I give you. So A cross B equals, so this notation I'm using here is just determinant notation. So we put I, J, and K in the top row, so our unit vectors. Then in the second row, we put the entries from A, whatever vector comes first here. In the third row, we put the entries from B, whatever vector comes second here. So for us, this is A1, A2, A3, and then B1, B2, B3. Now, how do we go about computing a determinant? What you do is this is going to be equal to, so we have a 3x3 determinant set up, but we're going to end up having to compute 2x2 determinants, but I'll talk about how to do that as well. So the first thing that we set up is we ignore this first column as well as the first row. So you're going to ignore this I, the A1, the B1, you're going to ignore the I, the J, and the K. So we're only looking at these four things right here. So we put them into a 2x2 determinant. So A2, A3, B2, and B3. And then we are going to multiply that by the vector I. So whatever column that we were ignoring, that top entry goes right here. So, and I'll show you how to compute this 2x2 determinant, so don't worry about that. Now there's an understood plus sign in front of here that our sign is going to alternate. So now we're going to move to the next, ignore the next column, but now we're going to have a minus sign right here. And then we're going to do a 2x2 determinant. We're going to ignore this column and we're going to ignore that row. So we're just left with A1, B1, A3, and B3. And that's what's going to go in here. So A1, B1, A3, so 3, sorry, and B3. And then whatever column that we were ignoring, we take that top entry, we put that out here. So we're going to compute this, and I'll talk about it, compute that, and multiply by j. So plus, minus, plus, our signs alternate. We're going to have a plus sign right here. We're going to ignore that last column as well as the top row. So we're just left with A1, B1, A2, B2 to go inside of here. So A1, B1, A2, B2. And because we were ignoring the K column, we're going to put a K on the outside of there. Now, how do you compute these 2 by 2 determinants? You do A2 times B3. So A2, B3 minus B2 times A3. So you do this what's called the main diagonal, and then you do what's called the off diagonal, minus the product of the off diagonal entries. So minus B2 times A3, and we still leave our I out there. So now we're just going to have some number, whatever this number is, multiplied by I, and then minus A1 times B3 minus B1 times A3. And we still have our J. We don't want to forget about that. And then lastly, plus A1 times B2 minus B1 times A2. And then we're going to multiply that by K. So if you want to, you can remember how to do this process just starting from here, or you can try to memorize that. I have a terrible memory, so I'm better with processes than I am with memorizing a final formula. Either one is fine. I caution you to the fact that in your textbook, this is a plus. They've distributed this minus sign right here. So they have this term is negative and that term is positive. But it's the exact same as what I have. They just distribute the negative sign. But the general approach to computing determinants for 3 by 3 and beyond is that we alternate that sign. So they alternated the sign as usual, but then they distribute it. So please don't get confused between what's in the textbook and what I have here. They're the exact same thing. So you pick whichever one you want to memorize and memorize that one. All right, so now that we have that, let's go and do an example where we actually compute a cross product. So I'll talk about what the cross product means and what we get from it, but for now, just know that that cross product gives us a vector. We'll talk about some details, some specifics about this vector after we do an example. So we're going to do number 4 on page 735. And it says in exercises 1 through 5, find A cross B and C dotted with A cross B. So we're given 3 vectors. The vector A is 3, 4, 12. The vector B is 3, 4, negative 12. And the vector C, which is 1/8, negative 1/12, and 1/16. 1/8, negative 1/12, and then 1/16. All right, so they want us to find A cross B. It's the first thing that they want us to find. So A cross B. So if you want to just plug in the stuff directly into that formula, knock yourself out. I'm going to quickly go through the process again just in case we didn't quite catch it the first time I went through it. So you always put I, J, and K at the top. Whatever vector comes first in the cross product, that goes right here. And you have to do it in that particular order. Otherwise, you'll have the negative of the vector that you wanted. So this is 3, 4, 12, and then 3, 4, negative 12. 3, 4, negative 12. All right, so this equals, so I'm going to ignore the I column and then ignore that row that has the I in it as well. So I'm going to have 4, 4, 4, 12, negative 12, and then I. Then I'm going to have a minus sign. I'm going to ignore the J column and put everything else in the 2 by 2 determinant. 3, 3, 12, negative 12. Don't forget to put my J back there. And then plus, ignore the K column. And I'm going to put 3, 3, 4, 4 is what remains. 3, 3, 4, 4. And put the K right there. And now simplify this. So 4 times negative 12 gives us negative 48. Then minus 4 times 12 gives us negative 48 again, times I. Then minus, open parentheses, 3 times negative 12 gives us negative 36. And then minus 3 times 12, which also gives us negative 36. The J. And plus, open parentheses, 3 times 4 gives us 12, minus 3 times 4, which gives us 12 again. And we have our K. So now we have the vector negative 96I and then plus 72J and plus 0K. If you want to, you could leave off the K component since we just have 0 of those. So that's our cross product. That's how we would do that. And you again, like I said, you could have plugged directly into this formula and gotten there. But now you've seen the process one more time. Now, the other thing that the problem asks for is for us to compute C dotted with the vector A cross B. So C dotted with the vector A cross B. So now we have 2 vectors to use. We have C, which they gave us, and we have this new vector A cross B, which we just computed. So now we just go back to computing dot products, which we already know how to do. So 1/8, negative 1/12, 1/16 dotted with the vector negative 96, 72, 0. All right, so now we're going to do 1/8 times negative 96. So 1/8 times negative 96 just gives us negative 12. And then plus negative 1/12 times 72 gives us negative 6. So negative 6. And then plus 1/16 times 0, which gives us 0. And we just get negative 18 there. All right, so this is how we go through and compute a cross product. But once you have a cross product, you have a new vector, and you can do all the things that we had previously done with vectors with that new cross product vector. So now let's talk about what we get when we take the cross product. So I talked about when we did the dot product. The dot product tells you the tendency of 2 vectors to point in the same general direction. What do we get when we compute a cross product? We know we get a new vector, but what are some characteristics of that vector? What's a key characteristic for us of that vector? So if A is not the 0 vector and B is not the 0 vector, then A cross B is a vector perpendicular to both A and B. All right, so the cross product, yes, it gives us a new vector, but it gives us a vector that's actually perpendicular to the initial two vectors that we had. So one way to figure out how it's perpendicular, well, first let's just look at three vectors that are perpendicular to one another. So we can use, or two vectors that we can take the cross product of and get a new vector that's perpendicular. So you all have already seen this in our set of coordinate axes. So if we look at our coordinate axes, so inherent in our set of coordinate axes are the important unit vectors I, j, and k. So there's I, j, and k. Now we don't have to do cross products with unit vectors, of course, as we've just seen, as we weren't doing using unit vectors a second ago. But these vectors, say for instance, if we took and we did j cross k, if we were actually to compute j cross k, we would get the vector I. So you can go through and do that just as practice, because you know what the vector j is. The vector j is 0, 1, 0, 1, 0, and the vector k is 0, 0, 1. If you went through that cross product process that we just did, you would get the vector I, which is 1, 0, 0. Now, there's a specific direction that that cross product vector is going to point in relation to the vectors that you're taking the cross product of, and that is determined by what's called the right hand rule. So if you take your right hand, you have to use your right hand when you do this, and you imagine that, so my fingers form a vector where this is the tail and this is the tip. My fingertips are the tip of the vector, and then the rest of my hand, or you can imagine my entire forearm if you want to, that forms. So I have a vector A would be my fingers. So remember, this is the tail, this is the tip, and then the tail of my other vector would be at my knuckles, and you could say my elbow, for instance, is the tip. So now my two vectors are touching right here. My thumb would point in the direction of A cross B. All right, so remember, this is A, this is B. The vector A cross B is going to point in the direction of my thumb, which is coming directly out towards you all right now. So using that same rationale, you could try to figure out in this, with this picture that we have here, using that right hand rule, if J cross K, is that going to point in the I direction, or is J cross K going to point in the negative I direction, which the negative I direction would be directly into our paper like that. That would be the negative I vector. Or you can also do the same thing with I cross J, or I cross K, or K cross I. So that's not going to be too pressing now. The key thing for us is that this is the cross product is a means by which to get a vector that's perpendicular to both the original vectors that you started with. The right hand rule isn't going to be that pressing. I'll mention it a little bit later, or a lot later in the course. In chapter 15, I may briefly mention it, but it's just a visualization thing in general. All right, so we'll stop this video there, and then I'll continue and talk about a little bit more of 11.4 in our next video.